Technology is altering our lives so fast, it sometimes seems we're entering a world that's unfamiliar, even forbidding. It's easy to forget we've accepted change many times before. In Britain, 200 years ago, life for most was simple, isolated, and governed by the seasons. Then, fast enough to be called a revolution, everything changed. Machines extended man's physical abilities. People moved to the sources of energy and raw materials. Towns and cities grew. It began in Britain, but it affected the world. Some resented it. Most saw that it was inevitable and welcomed the benefits: health, education, mobility, and a mass of new goods. At the heart of this industrial revolution was a communications network to move materials, products, and people. A national system of canals. Roads fit for all seasons. Last and most important, the iron arteries of the Industrial Revolution, the railway. The creators, the heroes of this network, were a new breed of men, engineers. Thomas Telford, father of the British canal system. Macadam, who developed the weatherproof surface for the roads. Stephenson, who pioneered the railway steam engine. And perhaps the greatest of all, Brunel, whose achievements spanned almost every field of communications engineering. Today, there's a new revolution, quite as significant as that other great upheaval, and it too is based on communication. It was begun by a Scot working in America. Alexander Graham Bell, when he invented the telephone, can scarcely have imagined where it would lead. It was the beginning of the information age. People could talk over tens, hundreds, thousands of miles. There had to be a way to connect their calls. Operators were employed, but with large networks, a manual system becomes impossibly complex. A way of linking subscribers automatically was needed. An American, Strowger, found the answer. A system that's had almost 100 years of effective, reliable life. But its use of moving mechanical parts means it's slow and expensive to maintain. And as it carries an analog signal, a current fluctuating in response to the original sound, it suffers from noise and error and isn't well suited to multiplexing, combining many signals on the same line. A British engineer, Alec Reeves, from Standard Telephones and Cables, made the crucial next step, a way of encoding the speech signal so it could be rendered in digital form, the language of the computer, a system he called pulse code modulation. It transformed telecommunications transmission, improving quality and reliability and enormously extending the ability to multiplex. But its potential was far greater. The telephone network was designed for speech alone. With PCM, it could also transmit the digital signal so vital in today's society: high-speed computer data, telex, and moving pictures. Throughout the world, telecommunications manufacturers have been developing switching systems to realize the promise of a fully digital network. These STC engineers are helping create the British solution, a system ahead of any other. System X. Unique and uniquely achieved. For System X is the outcome of a partnership embracing the operational experience of the UK Telecommunications Authority, British Telecom, and the development skills of its three principal suppliers, GEC, Plessey, and STC. STC's special contribution to System X was not restricted to its design and development, but extended to the creation of manufacturing methods as advanced as the system itself. STC is ideally placed, with its own resources for components, semiconductor devices, and printed circuits, as well as for the assembly of finished systems. computers transfer design information directly to the manufacturing equipment, controlling every stage of production from drilling the boards on which each printed circuit is built. Using the most up-to-date microelectronic technology, System X will fit into any existing communications network, however simple or advanced. This STC factory is contributing to the 1.5 million lines a year British Telecom will install to modernize the whole UK network. The key to System X's flexibility lies in its basic architecture. It's built from standard modules, collections of printed circuit boards that can be arranged to create different kinds of exchange, local, tandem, trunk or international, or exchanges which combine several of these functions. This means telecommunications authorities buy only what they need to satisfy their immediate requirements, adding new facilities or extending their exchanges later. System X is a full stored program control system. Not only is its hardware modular, but so too is the software that controls it, giving immense flexibility in the operation, maintenance, and evolution of the system. Common channel signaling enables calls to be routed much faster and more reliably than in conventional systems, and allows for the introduction of new services and facilities to be extended over the whole network. And as change is governed by computer programs, the system can be extended or new facilities introduced very simply and with no disruption to service. As each exchange is assembled, testing and checking continues to monitor reliability and ensure the precise requirements of each customer are met. System X is fully compatible with existing networks, electromechanical, electronic or digital, so an administration's investment in its present system is safeguarded, and it's designed to accommodate future technology. STC's contribution to System X has been applied to its installation as well as to its design and manufacture. The facilities to make and test systems as advanced as this are far better provided in the factory than in the exchange building, and installing fully tested equipment saves time on site. So STC have developed MITRE, Modular Installation of Telecommunications Equipment Racks. Modules, collections of racks, are attached to a special steel spine and loaded onto a conventional lorry. For their journey to the exchange, they need no special treatment save secure fastening and protection from the weather. MITRE enables equipment to be delivered to any exchange, however remote or however difficult the access. Here, a clearance of only a few inches is no hindrance. MITRE relies on two ingenious developments by STC's engineers. A specially designed handling device supports the modules as they're lifted from the lorry. Then its hydraulic arms gently ease them inside the equipment room. To maneuver the units inside the exchange, STC have modified another great British invention, the hovercraft. For they move them on air. Minutes from its arrival, the equipment is positioned with an accuracy of a few millimeters, ready for final acceptance. MITRE won't only be invaluable in the UK. Systems for export will be completed in the factory, then shipped to their destination, ready to go into service much more quickly than by traditional installation methods. And when it's installed, the benefits of System X will be very quickly appreciated by telecommunications authorities themselves and by their customers. It will, above all, improve the heart of every administration's business, its range of basic telephone services. Call setup will be very fast, and there'll be a marked improvement in reliability and speech quality. A variety of revenue-earning services are offered. Automatic call transfer, automatic alarm call, teleconferencing, three-way calling, and many more. Because the system is computer-controlled, these can be quickly and simply introduced, helping the customer and providing new sources of income to the administration. A more efficient and detailed billing system is another valuable feature available through the system.
Hello? Simpsons.
But there's much more to System X than a better telephone service. Because it's digital, it's possible to create, as British Telecom are doing, an Integrated Services Digital Network, ISDN, carrying speech and data. This means an almost limitless range of entirely new services will become possible. They'll help private and business customer alike. However far from home, the busy executive will be in constant touch at any time.
Amelia. Yeah, Amelia, hold it. Look, it's 4:15 in the morning here.
2,189,000.
Oh, not bad.
Check that hasn't got through.
They haven't got it?
Well, Jack's on a holiday. You're the only guy who
Yeah, I can authorize it, but why couldn't...
could be handy.
Yeah, all right, hang on.
Because a digital network can be fully interactive, the combination of a portable computer terminal and a standard television set means he can transact business as well as receive information.
Okay, that ought to do it. Yeah, I'm meeting him in the morning.
But for my own satisfaction, can you remind me of the original cash profile that you gave me?
You really need that?
Data can be transmitted in fractions of a second, round the world if necessary, so complex records are instantly accessible, inspiring confidence and perhaps making the crucial difference between success and failure.
Hello, Karen. Hi.
As a fully digital system with digital concentrators, System X will help with the introduction of a wide range of other services for the business community. Electronic mail, high-speed facsimile, teleconferencing, and the transmission of high-speed computer data.
Fantastic. Okay, I key it in on 88 here, right? Okay, I'll see you next week. $456,000 from 1982 is a pretty good return, don't you think?
There's talk of a cashless society, and already there are moments when changes of plan can stretch anyone's resources.
Karen, it was wonderful. Thanks a lot. Yeah. Okay, I'm on the Wednesday flight. I'm not. Where am I? Singapore. American Express.
Would you like me to debit your account debit?
Yes, right.
This transaction terminal instantly verifies the value of a customer's account, eliminating delay and embarrassment. Many economies depend on industries remote from centers of population. A digital network will ensure sophisticated communication services can be provided to those who need accurate and relevant information, so vital decisions can be made on the spot. Terminals like these will also introduce public information services, bringing up-to-date information to every home and office.
Okay.
In a world of increasing complexity, we need to learn more and be prepared to acquire new skills throughout our lives. Using System X, information retrieval will be far more effective than with conventional printed materials and will be tailored to the needs of each student. The ability to switch data as well as speech means System X will encourage the introduction of techniques like telemetry and telecommand, the ability to monitor and to control processes that may be inaccessible or dangerous, like the operation of a hydroelectric power plant.
so, how does it feel?
The benefits of System X will be felt on a much more individual scale, too.
Got our X-ray back, but I needed to compare it with the ones that they took 6 months ago of you in Toronto. They should be coming up online quite soon.
Today's jet travel means access to medical information is often difficult. System X will make this easy.
I'm ready to fly.
And doctors, even if they're far from centers of expertise, can take expert diagnostic advice or information on a problem with which they're unfamiliar.
Here we are.
In most environments, System X will improve the quality of life for individuals and the prosperity and efficiency of an economy. To realize these benefits, communications administrations seek a manufacturer who can understand and satisfy their individual requirements, a role for which, as Britain's leading telecommunications exporter, STC is ideally suited. STC's engineers have built and installed electronic systems of all kinds in every environment, from complete cable networks to sophisticated transmission equipment. The company has been responsible for the majority of the world's undersea communications systems, so it's learned to forecast and analyze the needs of communications authorities, as well as to plan and build equipment to meet them. The special requirements of submarine communications means, too, that the company has an enviable reputation for quality and reliability, for they must work without failure for 30 years and more deep under the sea. This experience is already being applied to the development and marketing of System X. With British Telecom and the other manufacturers, STC is a partner in British Telecommunications Systems, BTS, an organization that is promoting System X throughout the world. Introducing System X may mean staff must learn new skills. Like many customers, STC's engineers have made the transition from an electromechanical to a fully electronic world. A training program involving more than 1 million hours a year has been so successful, British Telecom have asked STC to train many of their engineers and instructors. Now there are specialist courses to help engineers from overseas administrations with the installation, operation and maintenance of System X exchanges. They're already discovering that the benefits of System X are by no means restricted to the new revenue-earning services they can offer their customers. Its day-to-day administration is much simpler than with alternative systems. Much of the work is done automatically by the exchange itself. Faults can be diagnosed from the remote operation and maintenance center, where engineers can be in constant touch with staff at the exchanges. It's a simple matter for a faulty board to be removed for test and repair. From its experience with the UK's digital system, STC can design systems to meet the needs of any area in the world, supervise their manufacture and installation, and give practical help with operation and maintenance. And British Telecom, too, are prepared to pass on their experience in the running of System X exchanges. The backing of British Telecom ensures continuity of equipment supply and software support, and means the evolution of the system is based on the operational experience of Europe's largest communications network. System X, then, is a fully integrated digital switching system. Its modular design and computer-based technology will radically improve any existing telecommunications network and offer an almost unlimited range of entirely new services. It's already helping to create an information revolution as far-reaching as the industrial revolution that preceded it. It, too, will bring change, and a world which may at first seem unfamiliar. But history shows the benefits of change are quickly appreciated. The electronic office made possible by System X means complex jobs like this architect's will be especially enhanced. Information will be available from any source and far more manageable than on paper. And it will be integrated with the creative skills of the individual to make his work more satisfying and more effective. The introduction of optical fiber networks will further extend the capacity and flexibility of systems like this. There'll be other benefits, too. As the services provided by System X will be available to every subscriber, wherever they are, Some may exchange the busy city for a quieter and more congenial working environment. System X will improve the lives and the work of individuals, as well as the efficiency and prosperity of businesses and nations. We know change is continuous and inevitable. System X provides a communications network that's not only meeting the needs of the present, but has the capacity and flexibility to meet those of the future, too.